Alright, so I'm getting a lot of questions about how to complete the square when there's a number in front of x squared, or there's a number that's not 1 in front. So, like number 11, number 12, 13, 17, 18. So notice how, like on number 12, for example, there's a 5 in front of x squared, whereas at 14, of course, the invisible 1. Completing the square is a lot easier when there's no number in front, okay? But it's not impossible. All right, so let's go over number 12. So in order to complete the square properly, I have to make sure that there's no number in front of x squared, or whatever the square term is, okay? So the best thing I could tell you to do is factor out the number that's in front. So if it's a 5 in this case, factor out a 5, okay? So if I factor out a 5 from 5x squared, I'm left with x squared. Factor out a 5 from 20, I'm left with 4x. Now the 96, you might say, well, wait. I thought when we factor, we have to factor out everything. Technically, when you're solving by factoring, that's correct. But it says we're going to solve by complete the square. Complete the square has one little caveat that you can actually use in this case. I'm actually going to leave the 96 out of it. Okay? I'm going to leave the 96 out of it because ultimately, when I solve this, you'll see that it's all going to balance out. Okay? So notice how I took a GCF out of the squared term and then just the linear term. So I took a 5 out of 5x squared, leaves me x squared. Took a 5 out of negative 20, leaves me negative 4. And you'll also notice I let this glaring blank spot right here. All right, and that's okay. There's actually a reason for that, because now we're actually going to complete the square with what's in parentheses. So see how it's x squared minus 4x plus 4, as hopefully you guys remember because you've seen some of my other videos, to get that other term, or the missing term that completes the square, which would make this a perfect square trinomial. We take half of b, which is negative 4 divided by 2 is negative 2. All right, actually I'll do the work right above it here. So negative 4 divided by 2 is negative 2. And then we square it, which gives me positive 4. So the number that would make this a perfect square trinomial is a positive 4. But as good mathematicians, we know whatever I add to one side, in order to keep the equation balanced, we have to add to the other side. Now, here's the last tricky part about this problem. Remember the 5 we factored out at the beginning, right? Okay. So notice how I added that 4 inside the parentheses. If I were to redistribute the 5 to all three terms, right, I would get 5x squared minus 20x, but notice how I would get plus 20. And I don't see that in the original problem, okay? So remember, if I'm balancing it, I have to have plus 20 on both sides, okay? So think about it this way. If I do 5 times 4, it's 20. That means I also have to multiply the 4 I put on the right side of the equation by 5. So see, if I put 20 on left, 20 on the right, they're going to cancel each other out. That's the goal. However, and the whole reason we complete the square is because they actually won't. And we're going to keep going on here. So the situation I just created inside the parentheses is a perfect square trinomial. So, again, if you need to know how the shortcut goes, watch my previous video. But essentially, square root the first term, x, take this sign minus, square root of the 4, which becomes 2 squared. And then minus 96 equals, and 5 times 4 plus 0 is 20. All right. And then this is just a regular quadratic equation, so I'm going to solve by adding 96. And that gives me x minus 2, or 5, excuse me, 5, x minus 2 squared equals 116. Divide by 5, and x minus 2 squared equals, I don't think 5 goes in the 116 evenly, so I'm going to leave it like that, and that's okay. Alright, then I'm going to square root, which is square cancels out the square root, so I'm left with x minus 2 over here. And then, if I added the square root myself, make sure I remember the plus minus, okay? And remember, with square roots, I can split this up into two separate radicals here. And then see if I can reduce 116. Okay, can I factor tree this out to get me the right answer? It's even, so 2 goes into it. And 2 goes into it, I believe this is 58 times 2 is prime, leave that alone. The 58 I can break down. Again, it's even. 2 and 29. And 29 is prime. 2 is prime. 58 is composite, so I'll cross it out. Look at that. 2 the same number. I am able to factor out a 2. So I have x minus 2 equals plus or minus 2 radical, and the 29 stays inside, all over radical 5. Okay. Add 2, and that gives me x equals 2 plus or minus 2 radical 29 over radical 5, which I'm sure you guys are like, oh, but we also learned about rationalization because I can't have a radical in the denominator. Okay, so the way I like to do it is move it up on top. So I'll just do the radical work over here. So 29, radical 5, and then whatever's inside stays in the bottom. And then 29 times 5 works out to be 145. So my final answer, x equals 2 plus or minus 2 radical 145 over 5 would be my answer for this problem. Okay? So obviously we went through solving the whole thing, but the key piece was factoring out that 5 to complete the square in the beginning. Okay? And let me just do one more example where I factor out something. Okay? Let's do number 11. Okay, number 11 here. And I won't do the solving part, I'm just going to do the factoring out what I need to. So it says solve by completing the square. But notice how in this one, if I take out if I'm completing the square, I'm going to take out whatever number's in front. So watch me take out this 7, and watch what happens. So n squared, so if I take out a 7 from 14, it's going to be 2. Now, there are two different ways to do this, and just because I like to keep things consistent as far as procedure, I'm going to leave the 21 out of it. And you might say, well, wait, I can actually factor out a 7 from 21. You can. But I remember how in number 12, I pushed 96 over, and I couldn't factor out a 5 from that. So I just want to keep the pattern consistent. So I'm going to push that 21 to the side. Okay. And remember, what do I want in my blank space? Half of 2 is 1. 1 squared is 1. And if I add 1 to the left, I'm adding 1 to the right. But remember, the 7 is going to affect that 1. So I also have to multiply this 1 times 7 over here. Okay. Now, you might say, well, what if I do want to factor out the 7? I just can't resist. Okay. You can, but remember, I want to try to keep the pattern and the procedure the same for every question. Okay. So this becomes 7n minus 1 squared minus 21 equals 0 plus 1 times 7 is going to be 7. Okay? And so you could solve it from there. So that is how you factor out, again, when there's a number in front of the squared term, or a is not 1, how you actually complete the square.